Hello everyone, I am Daniela Marin Villacorte. I work with data analytics, and today I'm presenting our latest project for the United Nations Development Program, the World Happiness Prediction Platform. We had the challenge that the UNDP collect massive amounts of socioeconomic data from 155 countries every year. GDP, health indicators, social metrics. We had this, but they had a problem. The manual processing took 2 or 3 weeks per report, and by the time insights were ready, they were already outdated. So they came to us with 3 questions. They want predict happiness score in real time as data arrives. Also, can we identify which factors governments should prioritize? Can we scale this globally to thousands of data points? And our solutions, it's around this is architecture about the project. We build an end-to-end automated pipeline that first ingests the data from multiple sources. And okay, well, here is the complete architecture of our platform. So this diagram shows the complete data flow from raw CSV file to final visualizations in this part. So let me walk you through quickly. At the top, we had 5 years of World Happiness Report data. CSV file from 2015 to 2018 years. In production, these will be live feeds from government APIs and survey platform. And the strat data, we had a function that constantly concatenate these 5 years of data into a single data frames. We had a transformation phase that in this phase we clean and transform the data, normalize column names, map countries to continent, and highlight missing value. And we had Kafka streaming, and in this part we had the producer stream data to Kafka at 1 message per second, simulations real-time arrival. And we had the consumer that received data load or training random forest model, makes predictions and storage then in a progress SQL. All of this happens automatically, no had intervention and no had human intervention. And also we had machine learning model. And so in this part I'm going to show you that the notebook, the model training notebook. We had in this part in this part this is our we had trained the model with different algorithms. I don't know how to say it, algorithms. And we had compared model compares about these models. So um, we trained three models: linear regressions, gradient Bossins, and random forest. In a linear regression, it's we had around the 7-8 percent accuracy. It's very simple. It's no represent. It's plain approximately 8, 18, 83% of variance in the happiness score. Indicated a good fit, but it's no. Then I'm going to explain that it's no represent the model for this case. And we had random forest and gradient boosting. And in the random forest, we had approximately 87% accuracy. We had used the model like the winner. And we had also used the gradient boosting regressor that it's very similar to the random forest. We had the similar scores about the score, but we had higher means square error. That this suggests we had the both ensemble methods are efficient in the modeling the data, but I prefer use the random forest regression for this case. And also we had in this part we had the features about the importance the model. We had that well, the model reveals what actually drives happiness. Economy, it's very we had 35% GDP per capita. It's the single strength predictor. We had also health about 18%. Life, it's very a health population is a happy population. That we have also generosity, that is 5%, that not given us or well given us a minimal impact. So this chart let me know that what feature is important to the resource. So now I'm going to show you the visualizations, and you can see that well, now I'm going to look at the look this chart at the business uh, intelligence dashboard. Um, we delivered it to UNDP. These are the actual visualization that minister program directors and also economists use to make decisions. And the fears I'm going to explain that at the top we had for key performance indicators that giving stakeholders health check about, well, I don't know. First, total predictions, we had 235. This is the complete test set in the productions. This number then grows continuously as new survey data arise. We had average real happiness 5.38. This is the baseline. These tell us the average happiness in our test data, giving context for individual predictions. And also mean square error. This is technical accuracy metric. If lower, that it's very well. Remember that when I say that, when I trying to explain why I know use the gradient boosting, it's very minimum, but I prefer the mean square error more lowest than that the gradient boosting represent. And this part, we had this, and they had this. So that is excellent performance, and I had mean absolute error. Also, since the happiness scale runs from about 2.5 to 7.8, this represent only 6% error. Highly accurate for socioeconomic predictions. Also, we had chart about predictions versus real values. I think that it's the most important visualization for understanding the model accuracy. The ACEs show actual happiness scores from the World Happiness Report, and the ACEs shows our model predictions. And we had a red diagonal line that represent perfection. If every prediction were 100% accurate, all points will fall exactly on this line. Notice this distribution it's even above or below the line. This is critical, that it means the model doesn't consistently over predict or under predict. The errors are random, which indicate a well calibrated model. I share about this, and we had outliers, and these maybe are countries with unique circumstances that are harder to predict, like nations experience political its crisis or economic shock, but these are rate exception. And now we had error distribution by range. This chart shows the distribution of predictions error. We had green bar, green, orange, red, and dark red. The key inside this distribution is about the low errors. The green bar dominates that tell stakeholders you can trust this prediction for a strategic decision. And we had the chart about the average happiness score by continent. And in other words, the key takeaway, the blue line and orange bar are remarkable close across all the continents. For the UNDP, this means you can deploy this system globally with confidence. It will provide accurate predictions in, for example, in Saharan Africa, just well like as in Europe, wherever you want to use this model, these predictions. And we had two table about the top 10 best predictions and top 10 worst predictions. It's obviously. We had in the first table, we had, for example, the first ID, well, the 525 ID. You can see the real value and predict value. It's similar, so the error is 0. And in the last chart about the top 10 worst predictions, you can see that the most highest error is 33 ID, that the real value is 6.46, and predict real value, and 5.3 prediction to predict, that is the error 1.43. Well, for summarize, it's very important for the stakeholders that knows the no model is perfect. We are transparent about fails, even worse error, that is represent only 88% relative errors. It's reasonable for the complex socioeconomic predictions. And so we had the recommendations. It's using these predictions as one input in decision making. And also we had expertise and human resource about the judgment. I don't know the word. Well, in the for ending, we had two charts. The first chart shows actual happiness versus predict happiness score. from 2015 to 2019. Notice how the lines track almost perfectly. Um, its mean or model doesn't just in this part in this year we had peaking around in this part and then declined to through 2019. That this means our model doesn't just predict individual data points well. It also captures global trends over time. And in this chart, it's simple. The shows our predictions year by year. For the UNDP, you can use these systems to monitor global happiness trends in real time and identify inflection points early, allow proactive response. And well, now I'm going to talk about the quantified results. We had time reductions from 2 or 3 weeks to second. That is 99% reductions in processing time. We had cost saving that eliminate the need for 3 full-time analytics per report cycle. And we had 75 reductions in labor costs, and we had people that led training in other areas about interpretation or yes. And we had accuracy 86%. That it's a good model for happiness predictions. Also, we had scale with Kafka architecture. We had scalable 2,000 records per second as the UNDP is paying to real-time surveys and social media sentiment. This system is scalable. I don't know how to say scalable. The most important that also the economic, social support and health. It's we had no. It's we notice that it's very important to for I don't know. And well, this is all. That it's that finished my presentation. I am happy to represent this project and this architecture for using this model, and then using this model for the visualizations. And we had to business impact for the company UNDP. Thank you so much.